Hi, and welcome to this video covering question 7 of the Leaving Cert Maths Ordinary Level 2020 paper, and it's paper 1. Okay, so we'll get stuck in. Now, as always, if you want to copy these notes, just email me at shanetroy@gmail.com. And if you subscribe, you get access to more playlists, whatever. So this question is one of the long questions in section B. Okay, so it's question 7 is the one we're covering. And part A, part 1 is worth 10 marks. Okay, so it's a fair amount of marks here. I looking through the question before we did this, and it's a fairly involved question. So like all things, you're trying to look at the very minimum at getting this low partial here. Okay, so we see that Pat buys a new car for €32,000. So sometimes, depending on how you like to answer, it's useful to write things down. Okay, so that's your new car. And then he trades in his old car and is given an allowance of 20,000. Okay, so that's 20,000, and that's euro, whatever, and that's his trade-in. Now, right there, I'm not even going to read anymore. There's a difference there. Okay, and that's the cost of the new car. Okay, so take that away, it's what, 12,000. Now, I'm fairly sure I need that, but we'll see. Okay, if not, look, I've wasted the time. If I do, even if I do nothing more, I probably have gotten the low partial. Anyway, it says he borrows the balance of the money from the credit union. Okay, so now that's the balance of that money is the 12,000. So one correct relevant step. His fixed monthly repayment over 3 years is 443.66, whatever. But that amount doesn't really matter, okay, in the scheme of things. It's just whatever. Now the question is, part 1, they're actually asking us, how much money does Pat pay in total to the credit union for his loan? Okay. No, actually, will I need that 12,000? Okay, so anyway, look, I don't think I need the 12,000 right now, but how to do this particular sum here? Let me just go to the next page where it's prettier. Okay, so I've actually done that there, even though I'm not sure if I even need it to be done here, but whatever. So that's the amount he's paying every month times the 12 months in a year times the 3 years. Okay, now put that to the calculator. I got 15,971.76, which would make sense. Like it's if I take it in perspective, if the car is costing me 12,000, okay, and I'm paying off money for 3 years, this number should at the very, very least be bigger than 12,000, okay? And it's what, a little over almost 4,000 bigger, which if you ever borrow money, like that's money you've given to the institution, okay? Right, so that's part A, part 1. Now part 2 here says, show that Pat repays as a percentage of the amount that he borrows from the credit union is 133.1%, correct 1 decimal place. Now that's a curse of a question. Okay, and I won't curse when I read it. But show the amount that Pat repays. Okay, so how much does he repay as a percentage of the amount that he borrows? That's a big long chunk as it is there. And sure, they're telling you the answer. Is it 123.1%? So how much did he borrow? Well, he borrowed 12,000. Okay. Now how much did he repay? If I go back one page, okay, 15971.76. Whatever answer you got there, 15791. Oh, I've forgotten. 971. It would be good if I wrote it down properly. So that's 971. And again, I've forgotten. 76. Decimals are awkward. Now, or as I said, whatever answer you got from part 1. Okay. Now, it's as a percentage of it. Now, you notice it's bigger. So you can do it in a sense. This is kind of cheating. Okay. Let's say I didn't know which way it was. Okay. And I say, look, if I do that, multiply that by 100 over 1 to get a percentage, or it could be the 15971.76 divided by 12,000. Okay. So as a percentage of the amount he borrows, and again, you're multiplying that by 100 over 1. Now, you might pick 2 ways to do this. I'm going to bring in my calculator. Okay, and just drag it across to the screen. Okay. So let's try it both ways. Okay, so if that was 12,000, fraction 15971.76. Now press equal again, get the decimal, multiply by 100, decimal place will move twice to the right, so 75. Okay, so I owe 75%. Okay, that's not what they're looking for. So maybe sit away. Okay, so let's go back. No, so 15971.76. I'm going to divide that by the 12,000. I can build this all into the one sum times 100. If I want to go with the over one, doesn't matter. But now that doesn't look like the answer, but that's it there. Now it's three decimal places on the calculator. The question does say to one decimal place, so that makes more sense now. You're looking to this number 9 here, the second decimal place. That's greater than 5, so the next number rounds up by 1, and you get the 133.1. So if you weren't sure, and like let's say you thought it was the top one, okay, and you said, no, this one's not right. Don't cross it out, just put a line through it. And you could declare this is your answer, okay. You will be, even though you declared this as the answer, it's wrong, okay. But the examiner can see this one here. So they'll, if they do it right, will look at that and award you marks based on that. Can't do it very often, shouldn't do it very often. But if there's times you're, which is it? Now, if you had actually done the question out, you probably would have came to the realization that this was your baby. Okay, it's what made sense, and you got your 133.1. Really, as I said, there's two things to do. Okay, just do both and then see which one makes more sense. Is a strategy. Now, it mightn't be the best strategy in the world, but it's a strategy. And look, that's the answer. If you know what you're doing, it can be quite simple and elegant. But again, when there's a lot of words, it's hard to figure out what's happening, in my opinion. Now, the next one says a sum of money is invested at R% per annum, compound interest for 3 years. Now, the thing about compound interest is the interest you earn in 1 year adds on. So you earn more interest the next year and the year after and the year after and the year after. And compound interest is a really interesting thing within maths, or even if you're saving. The earlier you save money for retirement, the more you'll have, because the money you get builds. Okay, and there's loads of analogies about the power of compound interest and all this kind of stuff. Now, 3 years isn't a huge amount of time. It says at the end of the 3 years, the value of the investment has increased by 33.1%. Find the value of R. Okay, so R%. Now, I think actually I'm going to go to the next page. I think you just pick any random number. Okay. So the answer here, I've given a formula, and it's from the math tables, but it doesn't quite match up. The R% from the question is this I value. Okay. So for lack of a better word, R% is equal to I. Okay. So I hope that's not confusing. But this is my compound interest formula. Now I'm not given any numbers, but I can take numbers. Okay. And if I go, I'm going to put in 100. Okay. If it increases by 33.1% of 100 is 133.1. So even though it's a fictional number I'm making up, I'm choosing it because it's nice and easily round in a sense. 100, 133.1. Then I can calculate what the I would have to have been. Okay. So I know everything else. I'm choosing the P to be 100. I'm saying if I do earn 33.1%, my final value will be 133.1. I know the T value is 3 years. All that's missing then is the I. And once I've realized that and put all the numbers in, I'm here. Now it's a matter of using algebra to solve for I. So everything has to move from, in this case, the right-hand side over to the left. So the first thing I move there is this 100. Now what's it doing? It's multiplying by the bracket. When it moves to the far side, what does it do? It does the opposite operator, so it divides. Okay, it's a very common mistake. People bring the 100 over and they subtract it. Okay, but it's to be divided on the far side. Now I'm going to express that here. Then I look and I go, right, okay, that's the same thing. If I divide by the 100, the decimal place will move the number of zeros. So it'll be 1.331. So that's all I've done there. I've made this fraction a little bit simpler. Now I'm going to apply more algebra. I'm going to bring this power of 3 across. When a power goes across the equal, it becomes its opposite. The opposite of cubing is cube rooting. And it cube roots everything on the far side. And now I'm here. Now, if I apply a cube root to this decimal, I'll probably get an even longer decimal. So I might as well leave it the way it is. Now, all I have to do to get I on its own is move this 1. What's it doing on the right? It's being added. What's it doing on the left? It's being subtracted. Okay. Now, that's a calculation your calculator can handle. So why not? Okay, I put it through the calculator, I got 0.1. And 0.1 in percent, the percent is per 100. So multiply it by 100. 0.1 by 100 is 10%. Okay. Now, does it kind of make sense? You got 100 euros in, I get 10%. So after year 1, I have 110. After year 2, I have 10% of 110. That's maybe 112. And then after the third year, I have 10% of 112 or 222. Okay. And then you can kind of, that make more sense. Okay. Now, that last bit probably didn't, but whatever. Now, I think that's part B. So part C here says it is estimated that the value of cars depreciate at a compound rate of 20% per year. Now, you're looking at a slightly different formula. Instead of compound interest, it's depreciation formula. So instead of a plus, it has a minus there, if you can see down the bottom. So those two formulas are in the maths tables in the financial maths section. And if you think about it, if you're going down by 20% per year, it's going down by 1/5. Now, it goes down 1/5 of that new amount in the second year, and then 1/5 of that even newer amount in year 3. So it goes down, it's not a linear decrease. Okay, it's going down in bigger, increasing chunks, if that's one way of looking at it. Because we're taking some time to kind of figure out what what compound interest is and compound depreciation is. Okay. So it says use this percentage to find the value of Pat's car after 3 years. Now, to give you a reminder that his car cost 32 grand in the beginning. Now, I could do this by multiplying by 20%, okay, and get my answer, then take that answer away from some minus answer, and that's equal second answer, whatever, okay. You could go down that path, okay, and do it like what, 3 times, 3 years, okay. And look, that's kind of how I would have done it myself in maybe junior cert. And then these formulas, okay, they weren't really encouraged when I was doing it. Just be the teacher I had, kind of encourage you to do that step-by-step method, okay. But this formula just does it in seconds. So if I write out the formula, that's an F, so I apologize, it looks something different. Again, that I is equivalent to R. So F is your final, P is your principal, I is your interest rate, and T is your time. So we know this is 3 years. We know this is 20%. Okay. Now, my principal is the 32K, and I'm looking for this. That's my question mark. Now, I've got it done out on the next page. Let's use it. That's my formula. I filled in all my information I just said on the last page. Remember, 20% is the same thing as 20 over 100, which is the same thing as 0.2. There's no difference between them. So that's all I've done here is swap that out. Now, I didn't even have to. I could have programmed this in the calculator using the percentage sign and gone straight to the answer here. But I took the intermediate step just to illustrate, again, what percentages are. If I put this to the calculator, it's going to give me a direct answer. So the final price is what, 16,384. If you put it through the BS meter, you go, look, I buy a brand new car. After 3 years, it's worth like half the price. But you may have heard people talk about you drive a car off the park and from the dealership, and it's immediately lost a whole pile of money. And they're not wrong. The older a car gets, the more it drops. Now, it mightn't drop by 20,000 a year after the first year, but whatever. That's just the reality. They're trying to pick a nice, comfortable answer. So 16 grand could be legit. Okay, what do I know? As long as it's not bigger. If the car went up in value, Like what car goes up in value after 3 years? I'm sure some cars do, but not your average family car. Now this says Pat's friend Caitlin bought a new car 3 years ago. Its value also depreciated by 20% per year. And they say it's now worth this price. Okay, find the original price. So it's the exact same formula, except this time, okay, T, your F is what we don't know, or I do know. So it's 17920. So it's the principal, the original price we don't know. It's still 20%, and it's still to the power of 3 years. So I have to rearrange this first. Now I'm going to go to my answer here because it's prettier. So I can bring, now this whole chunk here is being multiplied by the P. So the whole chunk can move, okay? And it all becomes divided on the other side. It doesn't become negative, okay? It was multiplying on the right. It's divided into everything on the left. And everything just happens to be 17920. That can go to the calculator, okay? And I got 35,000. That's the principal. So that case, my answer was bigger because look, but I was looking backwards at what the new price was. It's a nice round number. That's comforting. So hopefully I've done it right. That's a nice chunk of 10 marks. And I think we're pretty much there. Yes, look, that's question 7. It's a long old video, but it's a long question. The question 7, 8, 9 are usually longer. So if you want to copy these notes, just email me at shanetroy@gmail.com. And if you click to subscribe, you'll see the links to other playlists over the previous years. Thanks very much and hope it was helpful.